everyone. Welcome to Deploy by DigitalOcean. I am your closer for this conference. I'm stoked to be here. Really excited to chat with you about a startup's guide to application architecture. My name is Justin Mitchell. I've been helping people deploy applications for 10 years now, and I started a website called Coding for Entrepreneurs. And I really want to talk about two primary things: how apps work, or more specifically, how cloud apps work, and whether or not you should learn or hire. Spoiler alert, I think you should learn. But I'm also going to be answering questions at the end of this one. And if you have questions right now, go ahead. I'll try to answer these questions as they come. We have a little bit more time than some of the other sessions because we are the closer. That said, we have a lot to cover. So let's take a look. Now, first and foremost, you probably already know what this is. Like, this is something that we're all really familiar with. If you're not, perhaps you are a little bit more familiar now and still not. Here you go, right? So what are we looking at here? Well, here's a few more examples. And this, of course, is forms, HTML forms, right? So we see them everywhere. Inside of our major applications, forms are dominating just how these applications are built and run. And this leads for me to think, data is everything. Now, no surprise here, because our entire industry is called infrastructure or information technology. Infrastructure as code is on the brain. So the idea here is data is everything, and there's many different activities on how we can actually use this data or get this data or manage this data. You're already familiar with all of these different activities. And of course, they lead into that data is everything to me. And they are the basis, in my opinion, for all internet-based applications. Now, of course, I'm talking about value-add business-based internet applications, but the general idea here is these activities make up how we get data, how we manage data, how we can see data, how we can edit it. And this is actually encapsulated with an acronym called CRUD. Now, a lot of application developers know this really well, of course, because it really just describes all of the different activities that happen in managing that data. That's create, retrieve, update, and delete. We see this all the time and all over the place, right? So we see it on websites when we're displaying the data. That's likely an action of CRUD or a type of CRUD. In our applications, we also see that as well. Now, when it comes to modifying data, there's really two primary ways. As humans, we use those forms, those HTML forms. Software, on the other hand, uses APIs. That's how software does CRUD most of the time. Now, we already saw that CRUD is everywhere, right? So we've got it on Google when we're trying to retrieve a search. We're doing a search, we're doing the R in CRUD. And then when we create a new account or we log in, we're usually creating something in the database that is related to this. So that's C. And then, of course, when we're making posts and all that, that's all in there as well to be the main driver of CRUD, which is creating that data. And so when we actually look at this, technically speaking, we see that there's this input form at the very top, and that actually is how we feed into some sort of structured like data. Now, if we want structured data out, there's a really high likelihood that the database, like what you see here, is going to be structured. So this spreadsheet here is representative of what a database might look like, and that data is then pulled out through that retrieve phase. And we also see this on applications as well. So we just saw a web application. Here are mobile applications. Now, the way this communicates is a little bit different. We'll talk about that too. But the general idea is this same data can now power all of these different applications. Now, I think there's already some intuition to this. You probably already know because you use these applications all of the time, and you're probably very familiar with this. I'm just sort of naming things for you at this point, because I'm assuming that you're looking to learn how to build a startup application. And so if we think about this, if we think about CRUD and the other kinds of activities that happen in relation to CRUD, we think about this one. So you as a user, you're going to go to a website. Let's say, for instance, the Coding for Entrepreneurs blog. At that blog, what that's going to do is then hit up a web server. This web server will then forward that along to a web application. The web application is going to handle all of the logic related to the URL route. The web server can as well, which is pretty cool, but the web app also is what's going to integrate to your databases. So whether that's a structured database or a non-structured database, otherwise known as SQL and NoSQL. And then after the web server hits the web application understands the logic and then returns back HTML, CSS, and JavaScript. This, of course, is for web applications, right? So websites, web applications, this is roughly what's going to happen every single time. And this is called the request response cycle. Now, it's not always one way like this. Sometimes it's multiple directions, but generally speaking, this is the way we want to think about when we have URLs and how we're going to go about routing them. Now, this is also true for our mobile applications, right? So mobile applications also make a request to some sort of API endpoint. That API endpoint then goes through the web server, then it hits a web app REST API of some kind that also can still handle the logic going to the databases and all that. And then its data type will be returned is XML and JSON. So it's not really a whole lot different whether you're doing a web application or a mobile application, a software that you actually install. And so if we look at a website front end, it's composed primarily of three parts: HTML, CSS, and JavaScript. Now, it absolutely has to have HTML to be valid as a valid website. It doesn't need the other things, but the other things add some nice advantages that we'll talk about right now. So the web application is ran in a web browser. No surprise there. So the web browser is actually the application that's responsible for rendering out this code. So HTML code is fairly simple. It gives us some structure, just like that. You got a button here that you can say, click me, with an ID on it. Now, if we want to add some styles to it, if we want to make it look better, we use something called CSS, really just styles that style how the button might look and how it's presented. Now, this does a lot more than what we see here and can do a lot more thanks to advancements in how browsers end up working with CSS. And a lot of browsers are very forgiving when you make mistakes with HTML and CSS. That is modern browsers, of course. Now, JavaScript is unique because it adds a little dynamicness to the content, right? So on a button, we can add a click event, for example, that does something. Now, JavaScript can do a lot more than just that, but this is sort of the basis for a lot of web applications out there. And that, of course, is vanilla JavaScript, and there's no frameworks, just writing plain old JavaScript for this button to have some sort of click event. Pretty fascinating. Now, if we look at the back end, how the actual HTML, CSS, and JavaScript is even rendered, we look back to this right here, right? So we got our user going to a path for blog, right? codingforentrepreneurs.com/blog. That then is forwarded on to a web server. Now, there's a lot of different web server technologies out there. Nginx is one of them. Inside of Nginx, we declare a bunch of things that essentially forward this traffic down to our Django application that's running potentially on a whole nother server, right? So these can be two separate servers, actual virtual machines, actual droplets, completely separated from each other. And Nginx does this coordination between the two, which is fantastic. And it really allows for us to then write our own web application code that might have more sophistication than what Nginx provides, because Nginx is really just configuration, where that's a lot of web servers are really just configuration, where you got a web application, you could write all sorts of complicated logic in it in a programming language that you like. Right here, we see Django, and that just happens to be written in Python. It gives you some idea of what to do in a Django web application. But the idea here is we can replace this with Fast API, which is also Python. We can replace it with Express.js, which is Node.js. And we can do all sorts of really cool things with this web application layer. Now, I think so many people really focus on the web application layer as well as the JavaScript layer on the front end, which we'll talk about more in a moment. And of course, the web application then communicates to some sort of database. I have two different databases here. One is a SQL database, one is a NoSQL database. No surprise there. They can work in tandem, and thanks to all of these different technologies, including how Django actually works. So if we look at a full stack web application, this is it, right? We've got this request response cycle going on. On the server side, we handle all sorts of logic and also, looking up on the database. The database itself is not really attached to the internet, but the actual web server is. And then the web server then talks to the application server. And then on the client side, of course, we've got our websites, we've got our mobile applications. This also could be TV applications, you name it. It doesn't really matter as to what it is that the client side is, right? It's going to have this kind of cycle going on all the time with your application. And it's often to be like, oh, if you have a mobile application of some kind, the request response cycle is most likely going to go through an API endpoint of some kind that then returns back JSON data, not like a website where it's HTML, CSS, and JavaScript. So if we look at some front end tools here, this is how we can just make a website just that much more interactive, that much better looking. Just functionally speaking, it looks a lot better. Now, JavaScript frameworks is that other one that I was saying that really has some heavy influence on the current state of web application development, right? A lot of people want to build things in React or Vue or Angular for good reason. They add this dynamicness to the front end that just isn't really that possible with other tools. They also add complexity. So it's really an exciting level of tool that you want to add this dynamic content. You want it to feel as native as possible. You might opt for those JavaScript frameworks. Now, these days, I actually opt for dynamic HTML tools, which do a lot of the things that JavaScript can do without writing JavaScript. You just write HTML, and then your backend will help with the logic of managing all of these things. So HTMX and Hotwire are two examples of this. We're going to probably see a lot more of it as the capabilities of these, dynamic HTML tools come out and get better and better and better. It's a really exciting time for the front end because it's just getting better, which is the great part about all of it, right? So the JavaScript frameworks themselves are definitely well worth a look at if you want a super interactive front end. The dynamic HTML UI tools are, to me, the best for MVPs, right? So if you're building a minimum viable product, use the dynamic HTML so you get the similar feeling that JavaScript has without the overhead of JavaScript. Now, what I'm referring to here, this dynamicness, is like a like button, right? So if you click a like button, that usually doesn't reload the entire page. It just does a like. That is the dynamic, sort of feature that I'm referring to. Now, CSS frameworks help speed up how the web application looks. Like you can write just a few things in the CSS framework and it just already looks way better. If you remember back when I actually wrote some manual CSS for that button, that was a lot to write just to make that button a little bit bigger and a different color. These CSS frameworks have a lot of those things out of the gates. My now favorite is Tailwind CSS, hands down, for a lot of reasons, mainly being that you are very explicit on every single element what you want. It's not opinionated like Bootstrap. Bootstrap has its own opinion on how things should look and function and feel. They both are great. I've used both of them for a long time. I really, really like the way things are going on CSS as well. Now, HTML template engines are things that you might not end up using if you use a JavaScript framework. These are essentially allowing you to format your strings programmatically, right? Or programmatically. So you've got, like, you want to say, hello, so-and-so. An HTML template engine will change so-and-so to being your name, like, hello, Justin, I wanted to say that. Now, you've probably already seen these things broken when you get an email like, hello, insert name here. That is usually because somebody didn't render these templates correctly. These three right here, I think, are really good at rendering templates and will allow for all sorts of flexibility, as well as not get the hello, insert name here type of thing going on. So, of course, there's a lot more front-end tools than that. But to me, these are the ones that I go to all of the time, depending on what it is that I'm building and what I'm working on and what I'm using. But do keep in mind, it kind of goes from JavaScript being the most complex. Those JavaScript frameworks are incredibly complex. And then the dynamic HTML UI tools are less so, but still have their own complexity to understand kind of how all of it works and functions. But it's well worth a learn. Now, if we look at our web app backend tools, the web server gateway, that web server, there's not that many options as you're building out your applications. And a lot of times, depending on where you deploy, you won't have to worry about this at all. My personal favorite is Nginx and Kong. I typically use Nginx in all sorts of things because it's really just writing a single configuration file and basically telling the web server where to forward traffic if you need be. Now, the web applications, like I said before, there's so many of them out there. My personal favorite is probably Django if I'm building a full-featured startup application. Fast API has become one of my new favorites as well, depending on what my backend that I want. Express.js, if I need something in JavaScript written, Express.js is going to be the way I go, although those other ones are great too. Now, I did mention WordPress in here because you can actually use headless WordPress as an API service so that your JavaScript front end can actually consume WordPress, which is pretty fascinating. But then what you also get on the other side is, if you have somebody who needs to manage their data, they can still use WordPress. And there's not as much overhead for the backend. So if you really just want to focus on the front end, you might end up using WordPress API to really just drive that front end, if that's something that you're interested in doing. Now, data storage, there's a lot of different places on where we can store our data, right? So structured databases, these are fairly rigid, right? So if you want to change them, you have to do global changes. It can be done, but it's not straightforward. It's not easy because it's made to be fitting in this structure. So most of the time when you use these databases, you actually think about the structure early on. Think about all of the rows and columns that you want. Think to like an Excel spreadsheet, all the rows and columns that you want, or rather the columns that you want and how you're going to name them. You want to think about all of those things in advance. Luckily, in development, this is fairly straightforward and you can really iterate fairly quickly to make this happen. And if you do need changes down the line, there are tools to allow you to do something called migrations that really can modify these structured databases. Now, my personal favorite is Postgres for a number of reasons, but that's an option that also works really well with Django. That's probably the main reason. And then if we look at the not only structured databases or NoSQL databases, these tend to be a lot more flexible, although they can be incredibly structured like the structured databases, but they're not only that way. That's kind of the point. My favorite in here is kind of a toss-up. They're all pretty solid for what they do, and there are even more options than what we have here, like many things. And then the other places to store data are things like object storage, file storage, and block storage. Now, object storage is one of the things that you'll probably use as a web application developer or when you're building your web application, because this is where you're going to store your front end's images, your front end's videos, your front end's JavaScript, your front end's CSS. Right, that's where it's going to be stored, is in object storage most likely. You can use file storage or block storage, but it's not always recommended because object storage tends to allow for really, really big files or just have a lot of them come through. And most of the time, a lot of object storages have a web component to them. So you can actually access this data by just using a link, like a URL link, which is fantastic. Okay, so let's take a look at a sample architecture for a web application, right? And this is the one that I would prefer myself. First off, you got a user. That user's request goes into, the Nginx web server. Nginx then distributes it to 3 instances of Django. Wait, what's going on here? We'll talk about it in a second. And also to static files. That's an object storage most likely. Now, what Nginx can also do, something that I didn't mention, is do something called load balancing. So what you can do is with your single Django instance, you can actually scale it horizontally. So instead of spending more money on one instance, you can actually spend less money on more instances, thus load balancing, which is fantastic. It's the same code, but then you start to think about it as stateless. Like you're not going to store critical data in your Django application in a load balance thing like this, which you pretty much shouldn't do anyway. We can talk about that more if you have questions about it. And then like from the web application side, we also have a background worker. In this case, it's a Celery worker. That Celery worker does not touch the internet. Nginx does not talk to it at all. It's sitting somewhere else and it's its own instance and it's running. And basically what it does is it runs longer requests that shouldn't be in the request response cycle. Do you remember that thing from way long ago? That is what the background workers tend to do. And my personal favorite is Celery, especially for Python applications, but you can use Celery for all kinds of applications. It doesn't have to be just Python. And then of course, we've got our databases in there as well. Now, this entire sample architecture can be done on DigitalOcean, not as a huge, promotion for DigitalOcean, but it can be done. And this is like what's really cool. And it's really simple to do. In this case, we have 5 droplets that are running all of our various services. We have 1 for Nginx, we have 3 for Django, and 1 for a Celery worker. Right away, you might be like, oh, this is a little bit more complex than I'm ready to go for. And I totally understand that, but this is an absolute valid option. And, my guess would be this would cost somewhere around $80, maybe 60, depending on how you have it, which is actually not that bad given what this can handle. It can handle a lot and it can do a lot for you for your application for a long, long time. But of course, it's a little bit too complex. So what we want to see here is something a little bit more like this, a more simplified architecture. So you can really just focus on the code that you want to run in the case of Django and our background worker process. All of that can be on DigitalOcean App Platform running in containers. Now, if you don't understand containers, you've never heard of it before, essentially what it allows you to do is isolate your code so you don't have a bunch of dependencies. In this previous architecture, running each one of these little nodes, as in Nginx or Django or the background worker, all of them have system level dependencies that make it even more complex to install. If you thought just looking at this was complex, there's all of these other complexities to make that run and work well. With App Platform, a lot of those complexities are abstracted away for 2 reasons. 1, because of App Platform handling all of it, and then 2, because of Docker containers. And Docker containers do that isolation for you, and then you kind of pre-fill what it is that you're going to install. Containers are sort of all the rage right now for good reason. And it's because they're really easy to move around, share, and run pretty much anywhere. At Platform is one of those examples. And so to me, this is almost the MVP architecture, almost, as in that minimum viable product. Like if you were going to start an application today, what would I recommend you do? It's this. This is actually incredibly simple because App Platform can also allow you to run regular tasks on some sort of schedule. Those tasks will then be able to be executed outside of the request response cycle, thus giving you a much more simplified look at how to build these applications. Now, of course, this isn't the only tool that we want to use, as in Django is not the only tool we want to use. You might want to use a whole bunch of them, right? Fast API, Express, Adonis, Flask, any of those, all of those can run on App Platform because of containers. Because containers, if the container can run, then there's a really, really good chance that your actual programming language can run as well. And here's just a few examples of that. And so App Platform, of course, is a platform as a service. So they help manage all sorts of things. And in my opinion, using managed services, especially when you're starting out, is absolutely the way to go. Otherwise, you're going to have to think about all sorts of things that I just can't even cover in the time that we have here. And so here's a few examples of what's going on with these different architectures, right? So on the client side, we can have React.js talking through to App Platform, that MVP that we just looked at. Whether it's Django or Fast API, doesn't really matter, but that's all on the server side of things, and that they will communicate back and forth as needed. And this is the exact same thing using something like React Native for a mobile application. So React Native can build your mobile applications that you have to download and install, and all of that stuff is going to be integrated in with App Platform, right? So it's actually fairly straightforward on how all of this works. Now, to me, there's a lot of complexity in here, and I think it's straightforward because I've done it so much. But of course, if you have questions on what it is that you're trying to understand more here, or I just lost you because I was going so fast, please let me know, because I'm here to answer your questions. I'm here for you. But the general idea behind App Platform 2 is it runs on something called Kubernetes. Kubernetes is a great tool that allows you to deploy that much more often. So if we go back and we think about this platform as a service, all of this can be ran on a Kubernetes instance, which of course, DigitalOcean has managed Kubernetes as well. So you can literally deploy all of these on your own Kubernetes block, your own Kubernetes engine, and really have a powerful service going on with all sorts of different applications that are being ran. And that is somewhere where you could grow potentially if you really, really need to. Okay, cool. So we just flew through a lot of things. And to me, it's like, oh, are we going to be learning or hiring, right? And so I think these are like very straightforward answers. I said before, spoiler alert, you should learn. Now, first and foremost, if you're a bootstrap startup, yes, you should learn, right? Do you have a big budget? Well, even if you have a big budget, you should learn. You're bootstrapping. Do you have time? You should learn. You're bootstrapping. If you don't have time, you should probably still learn. Do you want to? Obviously, that's a huge driver. You should absolutely do it. And the key question you need to ask, if software is the primary driver of value, then you're going to want to learn. Okay. And then if we're going to go into the, funded startup, well, yeah, it's very similar still, right? We've got hire, we've got, kind of missed one there. And we do have a question. So what do we think about having a mobile app and a web app talk to the same API / backend? I think so. Mobile applications and web applications can run off of the same API backend. But if you create it correctly, you can actually redistribute it through Nginx if you need to, or using something like Kubernetes if you're starting to get a lot of load. But I would argue that the vast majority of web applications and mobile applications can absolutely run on App Platform, no problem. And that's true for a lot of platform as a services without needing multiple backends essentially to power your API or your web app. And then, of course, if you're a funded startup, then yeah, you should probably still learn anyway. But thanks so much for attending Deploy by DigitalOcean. Again, my name is Justin Mitchell. I realize I flew through this, and it's because there's a lot to talk about in a short amount of time. So yeah, I'm definitely here to answer any questions you guys have. There also should be a Discord link that you have to get questions answered and all that. So feel free to ask any more questions. I'll be hanging out for a bit to do so. And I mean, the more on the thought of like different kinds of backends, when you're first starting out, you're not going to have a multiple backends. You really sort of need to commit to one backend for a good amount of time. And of course, you don't have to control the backend. You can use third-party services for your backend for your application. And sometimes that's great. But a lot of times when you want to make a major change on the backend, it's going to fail. And this is why, like, that question of if software is a primary driver of your value, why would you actually outsource your backend to another company to manage it for you? It doesn't make a whole lot of sense in today's ecosystem. If you really want a simple backend with a simple database, I think like using Fast API or Express.js with MongoDB is the way to go. Absolutely, 100%. So yeah, if you guys have any other questions, I would love to answer them. Otherwise, again, thank you so much for attending. Thanks for letting me close this out. I had a good time doing this one. Yeah, hopefully we'll be able to see each other in person here in the near future. But yeah, that's it for me. So thanks again, and we will see you here soon.